Hello everyone, and welcome to the 20th video of the TypeScript Game Engine tutorial series. So in the last video, we added some 2D shapes with the ability to check if they intersect with other shapes, and then we went ahead and we added a collision component, which allowed us basically to attach a shape to that component, and is ultimately going to serve as the basis of what we use to detect collisions in the environment. So with that, what we're going to do in this video is we're going to continue by creating a collision manager, which is going to ultimately keep track of all the collision components that have been added to a particular zone, and it will continuously check to see if any collisions occur and notify via messages when those collisions occur, as well as the actual components themselves. It'll notify anything else that's listening for those messages that a collision has occurred. And that is going to be very useful for building in some game mechanics. Okay, so one of the things that we're going to need to do is, if you recall, in our I-shaped 2D interface, we do have a position. Now, this position is not the position of the shape in the world, as it were, at least not as we're going to be using it. You could use this shape for something else that's not collision, and that may represent its screen position or what have you, but in our case it's actually not quite enough information because it's part of a collision component that that then is attached to an object. So if we take a look at our hierarchy here, we have our duck that has a transform position of x and y 100, and then the collision is actually attached to that. So really we should be checking our collision based off of that 100, 100, not the default 0, 0 position of the shape. And so when we do our collision checks against all the collision components, we're actually going to have to take that into mind. So in order to do that, what we're going to do is we're going to, in the collision component itself, create another method. We'll say public get, and we'll call it getPosition for lack of a better term. And this is what should actually be used over the shape's position. So in this case it's going to return let's have this return a vector, vector 2. We're going to actually have to replace this class when we go to 3D down the road, but for now I'm not going to worry about that. So what I want to do is return this.shape dot. Okay, before I do that, I want to add one more thing to our vector 2. I think vector 3 already might have this. No, it does not. So I'm actually going to add this to both just to make sure that we have it when we need it. I'm going to add a public clone method. It's going to return a vector 2. And we're going to just return a new vector 2. And we're going to say this._x, this._y. And I'm going to copy this to vector 3, all the way at the bottom, just like the other one. This is going to be vector 3, and it's going to take this._z. Great. And the reason that I'm adding that is because I don't want to actually be modifying the position of the shape in this method. So I want to say this.shape.position.clone. And then to the cloned copy, I want to add this.owner dot transform dot position. And that's going to be a problem because that's a vector 3. I'm going to have to add one more thing to vector 3, just as a convenience. I'm going to say to vector 2 and return vector 2. Return new vector 2, and I'm just going to pass x and y. It's just a nice way to be able to convert it to a vector 2. This is kind of a hacky thing, I guess. It's not ideal because it's sort of something that we'd only ever have to do when we're sort of trying to change things down from being 3D to 2D. But for now, I think we'll be okay with that. Okay, so all this is doing is basically taking the shape's position and cloning it and then adding it to the owner SimObject's transform position. Okay, so I do want to point out also that there will likely be issues with this when it comes to getting the world position and whatnot of nested objects. So we are going to have to come back and update this to handle nested objects / get world position. Because there are other things like rotations and things that are going to mess us up, but I don't want to get into all that right now because we don't necessarily need it, and it can be rather complicated. So for now, I'm just going to put a to-do note in here and come back to it later. You know what? Yeah, I don't actually want to handle it this way. What I'm going to do is I'm going to, in the update loop, I'm actually going to set the position of the shape to this owner transform position to vector 2. I'm just going to set this every time. This still is going to have the issue of world position. Need to get world position for nested objects. It's still going to have that issue. So that is something that I'm going to have to fix, but I'm basically going to update the collision shape to follow the owner's transform position on every frame. This probably isn't the best way to handle it. It's probably something I'm going to wind up changing again down the road, but for right now it should give us the most straightforward way to be able to check for collisions. So the next thing that I need to do is I actually need a load. Return type void. Just for the sake of completeness, let me just call it super.load. Let's see. Should be calling super on update and render too. Let me just fix that. I think a lot of my components aren't doing that, and that might be an issue. I just happened to notice. Okay, so in super.load, or I'm sorry, after super.load, we actually need to tell the collision manager that we exist. So obviously we need a collision manager to tell that we exist. So it doesn't really qualify as a behavior or graphics object or anything along those means, so it's actually going to wind up getting its own sort of category. So I'm going to create a new folder at the top level called collision. And to that, I'm going to add a new TypeScript file called collision manager. Okay. Namespace TSE. And let's go ahead and export class collision manager. This is going to have a private constructor because this is going to be a static class. So we don't want to be creating instances of this elsewhere. And we're going to have a private list of, it's going to be static list of collision components. So that's just going to be, for now, it's just going to be an array of collision components. Okay. And we're going to have another public static register collision component. And that's going to be component collision component. So this is a way to tell the collision manager that a component exists. So then we can say collision manager dot collision components. You know what, let's just call that components. Shorten that up a bit. Push component. And let's have an unregister component. And in this one, we're going to say if collision manager components, actually before that, index equals collision manager components index of component. So we'll get the index. We'll say if index is not equal to -1, then we'll say collision manager components slice index and for one component. And it will unregister the component. Let's do one last thing. Public static clear turn type void, and we're just going to say collision manager dot components dot length equals 0. All right. Have a public static update time, which is a number, turn type void. Okay, so what we're going to do is we're going to say for let C of collision manager components. You know what, let's actually do this. C equals 0, C is less than collision manager components dot length plus C. Let's just keep the index. We'll need a second loop, and we'll check against all the other components in the actual scene. So this is definitely not the most efficient way to do this, but since what we're going to have is a very simple type of solution, this is fine for now. We're probably going to want to do some sort of sort and sweep type method or something to filter down the amount of checks that we're actually going to do later on. But for now, I just want to get something very simple sort of up and running. Okay, so for let, we'll call this other equals 0. Other is less than, again, components.length plus other. Okay, let's actually shorten that to O for the iterator. Okay. So here, just to make this a little bit clearer, we're going to say let comp equal collision manager components C. And here I'm going to say the same thing except other and O, just to make it a little more obvious what's going on in the code. Alright, And so we're going to say if comp shape intersects other.shape, then we have a collision. Okay, and so basically for each one of these things, if we meet this criteria of the intersects method for both of those shapes, or one of the shapes, then we have a collision. And so what we're going to also do is we're going to keep a running list of collision data. We'll call this colliding components. And this is actually going to be a new class. So let's call this collision data. So we'll rename this collision data as well. Okay, and that's just going to be an empty array as well. Okay, so the collision data is basically going to say, it's going to have a public A, which is collision component, and it's going to have a public B, collision component. All right, and what we're going to do is we're going to check this list to see if a component already exists with those two, or a collision data already exists with those two collisions in it. So we want to then say for let D equals 0. D is less than collision manager.collision data.length ++ D. Okay, and we want to say if, let's shorten, let's say let data equals collision manager dot collision data D. So if data dot A equals, and we'll say comp, or data dot B equals comp, or data dot A equals other, or data dot B equals other. Okay, so let's actually swap these around a little bit. Okay, so we need to actually wrap this up like this. Okay, so we have two conditions that we could potentially meet. That means that we have existing collision data for this already. So if data.A is our component and data.B is the other, or data.A is the other and data.B is component. So if either one of those things are true, we have existing data. Update it. Okay? If that's not true, but we still have a collision, then we're actually going to be creating a new collision. Okay? And so what we're actually going to need to know in our collision data as well is the time that this collision occurred, right? So we're going to say time number. And we create a constructor, public constructor. And this is going to take time, dt, number. It's going to take A, which is collision component, and B, which is collision component. Okay, this dot time equals time, this dot A equals A, this dot B equals B. So here we have to create a new collision data, and this time is going to be our time. The A is going to be comp, and B is going to be other. And then we're going to say this dot collision data dot push call. Okay. Now the other thing is, if we actually have existing data and we're just updating it, we actually don't want to create this collision, so we need to add an else block and wrap this in it. Oops. Okay, so we either have existing data or we need to create it if we have a collision. Cool. So we're going to say data nope, this is actually wrong. This doesn't belong here. This else block needs to go. So if we have existing data, then we need to update it. But we need a way to actually check after we've gone through this if data exists for this. So let's say let created boolean equals false. Let's actually call this exists. So we're going to assume that it doesn't exist. If it exists, we're going to say data.time equals time, and exists equals true, and we can actually break the loop at this point. Because we found our collision data, we don't need to go any further. Now, down here, if not exists, so in other words, we've gone through all of our collision data and it doesn't exist, that's where we create a new collision. And at this point, we just simply create the new collision data and move on. Okay, so the next thing that we actually need to do is, once we've actually gone through all of these collisions and done all these checks, we need to loop through our collision data one more time. And this is to detect collisions that happened in the previous update but are no longer happening. And so the way that we do that is, if we had a collision that exists or was just created that was updated or created this frame, it will have a time that matches the time of this loop. If it does not match that time, then that means it was created in a previous loop and was not updated and therefore needs to be deleted. So at this point we can say if collision manager dot collision data D. You know what, instead of, let me again just save this off as data. Let data. Okay, so if data.time is not equal to time. So this is old collision data. We need to queue this in a list to be removed. So let's create a new array here, remove data, and it's going to be collision data array, just a new array, and we're going to say remove data dot push, and we're going to just push data, right? And the reason that we want to do that is because if we remove data out of this loop, while we're looping through it, it's going to screw our indices up. Now, we could technically run the loop backwards, and maybe that's what we want to do instead. But for now, we're just going to approach this sort of in the naive way, and not do it that way. Just to make the steps explicit. We can always optimize our code later. Okay, so now we've got a list of data that needs to be removed. And so now we can actually go through this data by saying while remove data.length is not equal to 0. We can say let index let me think about this for a second. So I need the okay. So we could say let index, so we'll get the index of the current remove data. So we'll say let index equals collision manager dot collision data index of remove data, the first element, right? So that'll get us the index of the data to be removed. Then we can say collision manager collision data dot slice, and we can say index one element, and that's it. So that's now been removed. Now we can say remove data dot shift, which is going to give us the first element of the array, which we don't actually need to do anything with it. We just need to get it out of that remove data element. So this is going to remove stale collision data. Okay, so now we have 3 basic states here for collisions to be reported. We have, we'll call this in collision. Actually, let's call this collision update. Date. On collision entry. Yeah, we'll call this on collision update. And then on collision exit. Right, so if we're just updating the data, we'd want to have some sort of callback to say, hey, we're just updating, or we're entering a new collision, or we're exiting a collision. And so our component should actually have methods to receive these events. So in our collision component, we're going to create a public. I'm going to say on collision entry, and we're actually just going to pass the data, which is the collision data. Collision. Oh, I'm not exporting that, am I? You know what? Let's just pass the other. The other collision component, because we don't actually need the data itself. We already know that we are one of the two components that are colliding here. So we have collision entry on collision update and on collision exit. Okay? And so now in our manager, really we can just say comp dot on collision update and pass other, because we already have that here. For collision entry, we can say comp dot on collision entry and pass other. So our on collision exit should probably say data dot a dot on collision exit pass b, which is actually making me think we may want to do this on collision exit for both. Whoops, that should be data.b. So here I'm thinking we call it for A and then we call B and pass A, just to notify both objects that the collision has ended. I think that's probably a good idea. We should probably do that across the board. This may be overkill, but I think it's important to notify both objects that the collisions occurred so that they can react accordingly. So in this case, we'll just call comp and pass other, and then other and pass comp. And I think that's the order that will go in. Comp, pass other, other, pass comp. And then in this case, it'll be A, pass B, B, pass A. And now, so every update loop, whenever we have collisions happening or not happening, the states of those things should be all managed nice and neatly inside of here, and we should be good to go. So the other thing that I want to go ahead and set up, just as a sort of way to test this, is I want to actually keep track of the collision data, sort of in a temporary visual way. So I think to do that, what I'm going to do is I'm going to add a temporary hack, and I'm going to say document dot title equals collision manager dot collision data dot length. Cool. Oh, I guess I need to string that. To do remove me. Okay, so that will that'll give us an idea if some of these collisions are if our collisions are actually working as we expect. Okay, so the next thing is in our configuration for our zone, we need to make a couple changes. So the first thing I actually want to do is I want to get rid of this inner component. We don't really need it anymore, so I'm going to get rid of that. And I just want to have the one crate. The other thing that I want to do is I want to add a collision component to this, and I'm going to call this test crate. I'm going to get rid of this rotation behavior too, because it's actually going to get in my way. So in test crate, I want to add a new component, and its name is going to be, let's go with test create collision. And then its type is going to be just collision. And the shape information is going to be the type. I can't type tonight. Is going to be a rectangle. The width is just going to be the width of the material. So the material, I believe, is 100 by 100. We'll try it and see if it works. And I'm actually going to copy this and just set its height to 100 as well. Okay, and so we should just have a simple collision test here. Okay. Also, the other thing I'm going to do is on the collision component, I'm going to do a simple console.log. Actually, I'm just going to say on collision entry. And then I'm going to pass, I'm going to say this, and then other. And I'm going to do the same for the other states, so I can see when these various things occur, and all the collision data. This is going to slow things down a lot, but it will give us a lot of visibility as to what's going on. Okay, that should be everything that we need to add. So let me go ahead and build this. And run. Okay. Alright, so we've got our one crate and we have our duck. So I'm just going to move him. And okay. I know what the problem is. There's a couple of steps that we missed. So I forgot to tell the collision manager that we exist for first off. So collision manager dot register collision component. This. That's super important. The other thing that's not happening is our update loop was actually not being called because I forgot to add that to the engine. So in the loop, we'll go ahead and call collision manager dot update and pass delta. Which actually, now that I realize there's actually something wrong with our update method as well. Because this is just the delta, not the actual total time. So what we need to actually track here is the total time. So if we are going to be updating this, we need to say plus equals time. If we're creating it, time is fine. If we're removing it, time is fine. However, when we're checking to see if it's going to be removed, we probably ought to be checking or tracking total time, static total time, and it's going to be a number, equals 0. So we also need to be tracking the total time in the collision manager as well. So collision manager.totalTime plus equals time. Then we can do our quality check. If data.time is not equal to collision manager total time. That definitely would have been a bug that would have come back to bite us later on. Okay. Should theoretically be all we have to do. And we are getting a crap ton of collisions for some reason. I'm really not sure why. Okay. Let's take a look at some of this data here. So our two collision components. So for some reason, we are getting a ton of collision updates and exits on every single frame, even well before we were colliding. Let me actually refresh this and pause this a little bit sooner. The intersects technically on the first frame is going to be wrong. Technically the collision component, this actually needs to be done on the load too. I think that's part of it, because the first frame is actually going to be incorrectly thinking that the components are all on top of each other because the position hasn't been updated yet. So when that's loaded, nope, we're still getting tons of them. So let's just refresh this real quick and pause. So if we look here, we're still getting a collision entry. Negative 2800. Where is that number coming from? That's really bizarre. So there's one important thing that I forgot to test against, and that is whether or not the other is actually, whether or not it's actually testing against itself. So we actually need to say if comp equals other, continue. Do not check against collisions with self. Because in this system, that is absolutely possible, because we're looping through the same collection twice, and it's definitely, it will happen where it's going to be checking against collisions with itself. So now if I go in here, yeah, now by default there is no collision happening, right? So if I go here, I should be able to go all the way around this crate and not have any collision. Okay, now I should be able to go into the crate and have collision entrances and exits. Okay, but it looks like it's continuously, so once I collide with it, it looks like I'm just getting infinite collision exits, which is weird. So that tells me that I'm probably not removing the stale collision data correctly. Oh, I'm calling slice here, and I think this is supposed to be splice. That would be why. It's not actually removing it because I was calling slice instead of splice. Okay. So now we have So entry, exit, entry, exit, entry, exit. Interesting. It's not doing update. I mean, it seems to be working, but it should be calling update instead of entry and exit every single time. Okay, so that fixed part of it. Oh. I think the safer way to do this would actually just be, instead of adding the time here, should just set it to collision manager total time. And then, oh, this is the other bug, okay. So I shouldn't be passing time here, I should be passing collision manager total time. Because otherwise this is never going to match up and it's just going to create it and then remove it because it's not equal on the next update. Okay, that was the bug. Now I'll bet it works. Okay. Now that's set to 1. Now it's set to 0. Okay. So we have our collision working there. Doesn't look like it's perfect though. You have to go pretty far in. So I'm thinking the circle is probably not rendering properly. So I probably need to have a look at the circle and see why exactly there's an issue with that. Because it's not actually updating unless the left side of this is over past this. So the collision, let's just take a look at the collision information here. So the crate collision, the shape is okay, that makes sense. Why is the position of this so far off? Okay, I think I figured it out. So when I'm doing the distance, I'm saying a dot subtract b. And the problem with this is subtract actually modifies that vector. So this really should be saying a dot clone dot subtract dot b. So if I go ahead and run that, that should fix the issue. Okay. Okay, that appeared to fix that issue. So if you'll notice, what's actually happening now is it would appear that our radius check is off. So it looks like it's actually determining that it's hitting down here somewhere. Like our box is here. And I'm thinking that is because it's not taking the origin into account. So if you recall before, our sprite actually has an origin defined. And that is not actually lining up with our collision. So what I'm going to do as a temporary measure is I'm actually going to get rid of the origin. on the crate. And I'm going to go ahead and refresh this. So it moves back into position. So that's a little bit more accurate. Still seems off though. It still seems off by about half that square. And I think the reason for that is because our origin of our duck is actually here. So it's actually calculating based on this. So actually I can put the origin back. Should put the duck. So let's see. On the animated sprite, I'm going to put origin here to center it to the duck. So I'm going to say x 0.5, y 0.5. I'll go ahead and run this. Refresh. And that's still off. So we're not... Okay. So that was part of the issue. Let me just put this, for good measure, back onto the test crate. Whoops. Not there. Here. Let's refresh that. Now that's probably going to be way off. Yeah, it's going to be way off. Okay. Okay, so what I'm going to do for right now to fix this, because this is actually going to be a lot more additional work to fix this the right way, so to speak, is I'm going to set a offset in the shapes. Okay, so what this means is I'm just going to copy offset here and circle 2D. So this will give me the ability to offset the actual mesh, or the shape rather, from the thing that it's connected to. So what I can then do is in the collision component, I can add this.shape.offset to the position. Okay? And in this case, our radius is 68, so I'm actually going to say the offset x is 68 and y is 68. Okay. And I'm just going to actually copy this. And for the test crate, the collision for that and the shape, the offset for that, since the width and height are 100, I'm going to set the offset to 50. Okay, let's just refresh this. Still wrong. Maybe this just needs to be -50, -50. Okay, so that was it. So the offset on the crate needs to be -50 in order to shift it the proper amount for this origin. This is something we probably ought to revisit later, because the math is a little bit weird on this. But for now, this will definitely give us what we need. The offset of the circle should be the same as its radius, whereas the offset of the rectangle should be -half of its width and height. Again, this is something we should probably adjust internally based on the origin, but there's no way to get that information from this component to this component. So I'm thinking the proper fix for this is probably going to be to add this origin, or take this origin away from here and actually add it to maybe next to the transform somehow, or maybe add it to the transform. But I'm not 100% sure how I want to do that yet. So for now, that is the fix. If we run this, we'll note that our collision happens properly from all sides, and this is a radius based off of the size of the sprite size of the duck. So and it also occurs when we're just over the crate itself. So I think I'm going to go ahead and wrap this video up here. This has gone on for quite a while now, and I think this is good enough on the collision for now that we should be able to start constructing our game. So I'm going to look into fixing some of these issues with collision off camera and probably update those in the next video. But if you follow this as is for right now, you will have working collision in your scene available. So I hope you enjoyed this. I hope you learned from it. Thank you guys so much for watching. If you haven't already, consider subscribing, and I will catch you guys in the next video.